right, so yesterday we were introduced to limits. Today we're going to look at one- and two-sided limits. Make sure that you should be taking your notes in Go Formative, and the first slide in Go Formative should have a code for you for the graphs to go with today, so make sure that you have that up in Desmos as well. All right. So far, we have looked at the value of a function as x approaches c from each side. This is called a two-sided limit because we're looking at both sides. We have seen examples in which a function approaches a different value from the left side of c than it does from the right side of c. This behavior can be described in terms of one-sided limits. Okay, so the notation changes a little bit. If the value of f of x approaches a unique number as the limit, as x approaches c from the left, then if you see how this says x approaches c, and then there's this little negative sign, looks like an exponent, then this right here shows that it approaches from the left, going this direction. If it just said c, that would be both sides, but this is just from the left. If the value of f of x approaches a unique number L2 as x approaches c from the, oh, it says left again. Oh, goodness. That should say right. Don't know how I missed that, sorry. Then the limit as x approaches c, there's a little plus sign right there. That means as the limit as x approaches c from the right gives me that value. So let's look at how this works. It says evaluate each limit using the graph. So it's graphed for us. When we look at this, this says the limit as x approaches to from the left. That negative means we're coming from the left to the right. So as x approaches 2, which is right here, from the left, then y is approaching -1. As the limit as x approaches 2 from the right, the plus sign means you start at the right and go this way. As we're approaching 2, that's going to be a +1. So we get two different values. Where yesterday when it was just 2, we would have had to say that it doesn't exist. All right, so let's look at how this works. We're going to evaluate the limits for each of the given functions. So this is number 1. So in here, we're going to look at number 1. Remember that this is the number that we're looking for. And it asks me for, I want the limit from the left and from the right. So the limit as x approaches -3 from the left, that limit is -2. And as I approach -3 from the right, that's at -7. All right, so that's -2 and -7. Because again, we're approaching from the left, we're approaching 3 here, and then from the right. All right, number 2. So this one, we're approaching 0 from the left and from the right. So as from the left, as x approaches 0, y is approaching 1. From the right, as x approaches 0, y approaches -5. So this is 1 and -5. Let's look at number 3. On number 3, I want, and when it has piecewise, for some reason it does this little thing, but that doesn't even really matter, honestly. If we're looking at the limit as x approaches -2 from the left, so as I approach -2 from the left, then I'm approaching -5. Ignore that part on these. I don't know why it does that, but I'm approaching -5. As I approach x is -2, as I approach that from the right, I'm approaching a +5. So this is -5 and +5. Right. So you look at number 4. You try number 4. You're going to approach it from the left, approach one from the left and one from the right. That means you have to actually look at your graph on Desmos. So as I approach x equals 1 from the right, and as I approach it from the left, I'm approaching two different things. So from the left, I'm approaching infinity. From the right, I'm approaching negative infinity. So infinity and negative infinity. All right, so then let's look at number 5. The limit as x approaches -4 from the left. And if you're not sure, I think you can tell that that should be the asymptote, but I also want to make sure that you know how to use Desmos if you're not super familiar with it. That's supposed to be an asymptote. So I can see if maybe, or I think it is anyway, if I want to see if it actually is my asymptote, I can hit this plus sign right here, and I want to add another expression. So I think that the asymptote is at x equals -4. So I'm going to type x equals -4. All right, and it's in there, but it's red. I can push and hold, and I'm going to change it to blue. So now I can see that. All right, so I can see that x equals -4, that actually is my asymptote. So as I approach from the left, I'm going to negative infinity. As I approach the right, I'm going to positive infinity. This is negative infinity and positive infinity. So then let's look at number 6 together. Well, this is a trig function. I want to know as x approaches pi halves from the left and the right. Well, my x-axis doesn't have the pi's in it like I would like it to. Okay, sometimes they'll be in there, sometimes they may not be. You have control over that in Desmos. So if I click on my little gear, or my little wrench right there, on my x-axis, I want to make sure it has the pi in it. So right here where it says step, I'm going to type pi. You literally just type pi. Then, when you click off of it, you can see that you have this in terms of pi. So when I am looking for the limit as it approaches pi halves from the left, so if this is pi, I could zoom in to see pi halves, but I can tell that that's pi halves. So from the left, I'm going to infinity. From the right, I'm going to negative infinity. But let me show you another way to do that as well. Let's say you don't remember how to put the pi's in there, or you don't want to put the pi's in there, or whatever. I'm going to take pi back out of here. So it's like it was to begin with. That's why I actually did that on purpose, so I could show you two different things. If I want to know what's happening at pi halves, again, I can add an expression, and I'm going to type in x equals pi, I just put pi, divided by 2, and I can change the color so I can tell what's what here. Make it green. And so then I can tell this is where pi halves is, regardless of whatever my axis says, and then I can tell what's happening here. All right. The other thing is there's a slider sometimes on them, which I'll show you in just a little bit. All right. So that's number 6. Did we write this down? So yes. All right. Let's look at the next part then. Existence of a limit. All right. So we just talked about one-sided limits. So a two-sided limit exists if and only if both the left and right limits exist and are equal. So that's what's basically what we did yesterday. We just didn't talk about it as being a left and a right hand limit. But we are looking at it that way now. So when I look at, so this says that the limit of x as x approaches c, it equals L if and only if when I approach from the left and I approach from the right, they have the same value and they're both L. So then this says evaluate each one-sided limit, one-sided or two-sided limit if it exists. All right, so let's look at number 7. When I look at number 7, I want to know the limit as x approaches 2. So if I'm dragging along here, well, at 2, it's undefined, right? So if you're not sure what that is, I mean, you can drag and kind of figure it out from this. But remember, we could also look at a table. And when we did the tables yesterday, we put in a bunch. But really, I just need to be on either side of 2. And I can tell when it's 2, it is undefined. But I can put in 1.999 for that one and 2.001. And then just look at these. And I can see that I'm on either side of 2. So that makes my answer here I'm sorry, either side of negative 2, not 2. So my answer is negative 2. All right. So let's look at number 8. On number 8, I want the limit as x approaches negative 1 from the right. So the positive means from the right. So as I come from the right, I'm approaching negative infinity. Now, if it was just approaching negative 1, I'd have to say it doesn't exist because they're different, but all I'm worried about is what's happening on the right-hand side. So as I approach it from the right, my answer is negative infinity. Let's look at 9. I want the limit as x approaches negative 4. So since it doesn't say from the right or from the left, I got to look at both sides of it. So negative 4, it's not the asymptote, it's like right here. And I can see that at negative 4, if I can actually get there, it's undefined. I can figure out what's on either side of it. I could, if you want to, again, make sure you know where it is, I could put in another line. So I could say, all right, I want x to equal negative 4. And then it puts that in there. I will make it orange. Green might be better. So as it approaches from either side, you could make a table, or you could just kind of see that looks like I'm getting pretty close to 4 there. I'm on either side of 4, so I think a positive 4 would make sense here. This, when you put in a vertical line like this, you get a slider down here. So right now we're at negative 4. If I move this slider, it moves my line. It does not help me on this question, but it might help you on some other things, because again, I want to make sure you also just know how to use Desmos. And if I did have it when x is, let's say, negative 5, and then I can just put my pencil there, and then I can make sure that it's at negative 5. I know right where it is to get to that point, whatever, but negative 4 is what we wanted. All right, let's look at number 10. Okay, so number 10, the limit as x approaches 3. So that looks like right here. You could graph it in if you wanted to. So think about, what is the limit as x approaches 3? As I approach from the left, it's negative infinity. As I approach from the right, it's infinity. And since they're different, they're not the same, that means it does not exist. Okay, doesn't exist because, once again, when I'm coming from the left and the right, I'd have to get the same thing in order for me to have an answer. So let's look at 11. 11, I'm approaching 0 from the left. Well, as I approach 0 from the left, I'm going to negative infinity. So this one has an answer. And the difference between these two questions here is that on 10, it was a two-sided limit. And from both sides, I'm approaching something different. But from just the left, I'm approaching negative infinity. That's why I get to have an answer to number 11. All right, so you look at number 12. I want the limit as x approaches 1. Right? Do you have an idea here? As x approaches 1, from the left I'm going to infinity, from the right I'm going to infinity. So remember, that means technically this does not exist, but we can describe it. I mean, it doesn't exist because infinity is not a number, but both sides are going to infinity, so we can say that the limit is equal to infinity. All right, so what do you think about 13? 13, the limit as x approaches 0 from the right. Approaches 0 from the right. Then y is approaching infinity. Then number 14, the limit as x approaches 0 there's no plus or minus, so that means I got to look at both sides. So think about what you think that answer is. As I approach from the left, I'm going to infinity. As I approach from the right, I'm going to negative infinity. They're different. They would have to be the same, so this does not exist. Let's look at 15. The limit as x approaches 5 from the left. Okay. As I approach 5 from the left, think about what your answer would be. Because when I approach from the left and I approach from the right, they're not the same. So if it just said the limit as x approaches 5, my answer would be does not exist. But this is a left-hand limit. So as I approach from the left, my y value is -1. All right, let's look at number 16. So the limit as x approaches 1. That means, so here's x equals 1, coming from either side. I can tell by looking that the limit exists. I just need to know what the y value of that is. And so I could trace, or we'll just do a table again for kicks. And I want to know as it approaches 1, so I would use 0.999 and 1.001, because when it's at 1, it's undefined, but I can see on either side of 1, I have to be approaching 0.5. (17) The limit as x approaches -2. So here I am at -2 right here. If I just substitute in -2, I'll get an answer. Okay, what I would substitute into this one right here. So my answer would be 3, but that's not what we're doing. We're coming from the left, it's approaching -1. From the right, it's approaching 3. But since it just asks for -2 overall, since those are different, my answer is does not exist. All right, 18. Approaching -3. Positive means from the right. So as I am approaching -3 right here, from the right, from the left, they're actually the same. I get 0. Alrighty, let's look at a couple of trig ones. Starting with number 19. So on 19, I want the limit as x approaches 0, and that little negative sign, that means from the left. So as x, here's 0, as x approaches 0 from the left, I'm going to negative infinity. As it approaches 0 overall, it would be does not exist because they're different, but we only care about the left-hand side, so our answer is negative infinity. All right, so then I have the limit as x approaches pi of -2 cosecant 2x. So on 20, now I could do a couple of different things here because I can't see pi because that's not what the markings are on my x-axis. So there is a way to change the settings, but there's also a way to put in a line. So let's kind of look at both. I can make this another piece of my graph. Since I want to know what happens as it approaches pi, I can put x equals pi. And there's my line. Let me change the color. Maybe. All right. So here's pi right here. Even though I don't have the step correct on my x-axis, doesn't matter. As it approaches pi, and this does not say from the left or the right. So when I go from the left, it's infinity. Come from the right, it's negative infinity, so that does not exist. If you don't want to type in or graph another line, then you can always go to the settings here and change your x-axis step to pi. That way you can see right there you're at pi. Either way, it doesn't really matter. Your answer is still does not exist. All right. So 21. I want the limit as x approaches pi fourths. All right, so here, since I can see clearly where it's going to exist, it's not going to be an asymptote, I probably want to go ahead and change the step and not draw in a line there. So I'm going to make that pi. So I can see if this is pi halves, this is pi fourths. You can zoom in if you want to so that you can see pi fourths, or maybe you can't. Maybe we just go to pi halves and then we know that pi fourths is in the middle of this. But as we are increasing to pi fourths, decreasing to pi fourths, I think I like this view better because I can see this is pi halves, this is pi fourths. So as I'm getting here, clearly it exists, and there's nothing that, like there's not a undefined there. So, and a decimal is not going to do me any good. So basically I can just substitute in what I know. As x approaches pi fourths, well, what is the sign of pi fourths? The sign of pi fourths is the square root of 2 over 2, and that's the value you're getting as a decimal. Should be an exact form like that. Okay, let's look at 22. X approaches pi fourths from the right. So once again, I don't have it in the right thing, so I can either change the step or I can graph a line. My pen has a mind of its own. It's pi. And I'm looking for pi fourths, so this is pi halves, pi fourths, so that's where an asymptote goes. And I'm approaching from the right. That means my answer is infinity. Okay. So let's look at 23. I want the limit as x approaches pi sixths. Right. So I'm going to change this to pi. And I'll zoom in just a little bit. I can get pi 6. There we go. You can click and drag. So as it approaches pi sixths from the right and from the left, I'm getting these decimals here, but all my trig stuff should be in exact form. I'm not getting an undefined there, so clearly it actually has a value. So I can just substitute in the value of pi sixths. So I would like to think in terms of the reciprocal. The reciprocal of secant is cosine. So the cosine of pi sixths, right? Think about what the cosine of pi sixths is. That's going to be square root of 3 over 2. So the secant of pi sixths is the reciprocal of that, which you can just do as 2 over the square root of 3. That's secant squared minus 3. So that gives me 4/3 minus 3, which is not 1/3. That would be like 4/3 minus 9/3, so that would be negative 5/3. That's what you get as your exact answer there. Last one. You try this one on your own. I want the limit as x approaches 0. Think about what that would be. Now, this is a trig question, and this is not in terms of pi. So I could do an x equals 0 line. I could change the step to pi, but I don't really need to because it's 0, so I don't really care if it's pi or not. But this just says 0. It doesn't say from the right or the left. So from the left, I'm going to infinity. From the right, I'm going to negative infinity. So this does not exist. Okay. And that's it. So you can go ahead and submit your notes in Go Formative. And your assignment today is in Delta Math. So get to work.